We have seen how we can use repeated multiplication of two or more terms when the bases are the same. By adding the exponents together, we are in turn adding together the number of times the bases are being multiplied. However, exponents come in many sizes. The exponents we used for the product rule were non-zero positive integers. Let's now talk about exponents of zero. We know that if a number is multiplied by zero, it becomes zero by the zero rule of multiplication. But in the case of exponents, what happens if you multiply a number by itself zero times? We can reason that this number will not be zero because there is no zero present in the computation. In other words, a zero only appears in the product if there is a factor of zero. How then do we evaluate 2 to the zeroth power? By itself, we can't figure out what this number is. But if we use it in an expression with another number that we do know, we can identify a logical explanation to what this number, 2 to the zeroth power, could be. We can do this with the rule we learned in the previous lesson, the product rule of exponents. Let's use the expression 2 cubed times 2 to the zeroth power. Using our previous understanding of the product rule, we can solve this expression even though we couldn't solve 2 to the zeroth power by itself. Let's simplify this expression using the product rule. We have 2 cubed times 2 to the zeroth power. This becomes 2 to the 3 plus 0 power, which becomes 2 cubed. Look at what happened. We started with 2 cubed, which in turn equals 8, times 2 to the 0th power, and ended up with 2 cubed, which equals 8. This tells us that 2 cubed was multiplied by something that allowed 2 cubed to keep its identity. Using this logic, we can apply the identity rule of multiplication and safely conclude that 2 to the 0th power must equal 1. That's right, the zero property of exponents is a type or manifestation of the identity property of multiplication. This means that any number raised to the 0th power is equal to 1. Here is a formal definition. If A is in the set of all real numbers, then A to the 0th power equals 1. We conclude that any real number, no matter how large or small, will become 1 if raised to the 0th power. There are a few unique ways in which this is taken advantage of. However, most of those uses are too advanced and left for some subjects within calculus. Let's now take a look at a few examples. Once again, pause the video after I display each example and see if you can finish them on your own. Number 1, 100 raised to the 0th power. This is an example to show that even large values are brought down to 1 when raised to the 0th power. As we stated when I displayed the definition, no matter what number, if it is large or small, will always equal 1 when raised to the 0th power. You could have 10,000 raised to the 0th power, and it will still equal 1. Number 2, negative 2 raised to the 0th power. In this example, we have a negative sign within the parentheses. Normally, when a negative number is raised to a power, it can return an even number if the exponent is even, or an odd number if the exponent is odd. However, because this negative sign is also being raised to the 0th power along with the 2, it also will become assimilated into the product. So this means even though there's a negative in this parentheses, the whole parentheses is being raised to the 0th power, and we are left with 1. Number 3, -1 to the 0th power. Here we have the negative sign outside of the exponent's range. Therefore, we will carry the negative sign into the product after we have calculated the exponent. So first we calculate the exponent. The exponent is being applied to this 1, not the negative. So we are left with -1. So we carried the negative sign over after we dealt with this part. Number 4, 2 squared plus 10x raised to the 0th power. These two terms have incompatible bases to combine because one of these terms includes a variable. However, the term with the variable is being raised to the 0th power. Therefore, after evaluating the exponent, the variable along with its coefficient will become 1, allowing us to combine the two constant terms. So this gives us 2 squared, which equals 4, plus 10x all raised to the 0th power. Anything to the 0th power equals 1. 4 plus 1 equals 5. Not all expressions or equations or problems that include a 0th power will equal 1 in the end, as we've seen here. Only the part of the expression that is raised to the 0th power will become 1. Number 5, -x to the 0th power minus 12 to the 0th power. After evaluating these exponents, this becomes a simple addition of two negative terms. We have the negative outside of the exponent's range, so we carry that over. X to the 0th power equals 1. Minus, which is outside of the range of the exponent, 12 to the 0th power equals 1. -1 minus 1 equals -2. Here we have a negative number as the outcome. Even though both terms was raised to the 0th power, we still ended up with a number not 1. We ended up with a -2. So here we see that sometimes 0th power can be used to bring out unique answers far than what we would expect. Number 6, 1/2 plus pi squared, all raised to the 0th power. Even though the inside of the parentheses seems difficult to solve or evaluate, the fact that the entirety of the expression is being raised to the 0th power makes the difficulty of this expression non-existent. This expression is all being raised to the 0th power, which means everything here becomes a big fat 1.